Okay, so this video is going to go through stoichiometry with gases. So just like all of the other stoichiometry problems that we've experienced so far in this course, we're going to be doing the exact same process. We still have to start off here with our balanced chemical equation. We still have to use our molar ratio in order to convert between different things within my balanced chemical equation, and then at the end I still can use all the tools that I have in order to convert to mass or volume or whatever I'm looking for of my final substance. So keeping in mind that your molar ratio must always be given to you in moles, or must always compare between moles. So that should always be your first step as you're going through any type of problem here. So let's look at a question here and see how we can solve this using our stoichiometry and all of our gas tools. So acetylene gas is prepared by reacting calcium carbide with water. What mass of calcium carbide is required to produce 235 mils of acetylene gas at 0 degrees Celsius and 101.3 kilopascals? So just like I stated, the first thing that we need to do is write out our balanced chemical equation. So I have calcium carbide, and that's a solid. I'm dropping that into some water, and that's a liquid, of course. And this produces acetylene gas plus calcium hydroxide. Okay, the reason that these state symbols are important for these types of questions is when I look at the information given to me, I need to know what it's actually referencing. So because I'm looking at volumes, temperature, pressure, I know that I'm dealing with gas law things. Therefore, all of this information is with respect to my acetylene gas. So again, that's my step one here, was to balance this chemical equation. Okay, so when I balance it, just have to add a 2 here for my water. Everything else is balanced and good to go. So in the end, I need to solve for the mass of my calcium carbide, but I don't have any other information about that yet. So I'm going to put that on pause for a little bit and write down all the information that I have about my acetylene gas. So I know the volume is 235 mils, but remember all of our volume must be in liters. So this would be 0.235 liters. I have a temperature. This temperature is given to me 0 degrees Celsius. Remember, temperature for gas law must be in degrees Kelvin. So this would be 273 Kelvin. And I have my pressure, and it's already in kilopascals, so that's fine. I don't need to change anything there. Okay, I'm trying to solve for the moles. So the only other thing that I need is this R value. So my R value is the constant, 8.314 kilopascals liter per moles Kelvin. Okay, so now that I have all that information down, then my second step is going to be using that ideal gas law in order to solve for the number of moles of calcium carbide. Of acetylene gas. So PV equals nRT. If I'm trying to solve for N, that means I need to get rid of this RT. So N equals PV over RT, and now I can substitute all of my information into this equation. So the pressure is 101.3 kilopascals. Again, I'm going to include all of my units here to make sure that when I rearrange, everything works out and all the units cancel out properly. For your R value, remember what I said in the last lesson that we're going to take that moles Kelvin, if it's on the bottom, and pop it up onto the top. And then my temperature is 273 Kelvin. Okay, so I'm just going to confirm that I've done everything correctly here. So if my units all cancel out, then life is good. So I have kilopascals with kilopascals, liters with liters, Kelvin with Kelvin. left with my moles, which makes sense because I'm solving for the N value here, the number of moles. All right, so N equals 0.0105 moles of acetylene gas. Okay, so again, I have moles of acetylene gas. I'm looking for information on calcium carbide. So now step 3 is going to be using my molar ratio to compare between calcium carbide and acetylene gas. I'm lucky in this case, it's a 1-to-1 ratio. Therefore, because I have 0.0105 moles of acetylene, I have the same amount hanging out of calcium carbide. So I'm just going to write that down so you have that in your notes. Okay, so I have the moles of acetylene of calcium carbide. I can figure out the molar mass of calcium carbide, and then I can use all of that information in order to calculate the mass that I need in the end. So just gonna move that over here. So step 4 is actually figuring out the mass. So again, we said I need to know my molar mass of calcium carbide. So using my periodic table, I found that that's 64.1 grams per mole. And I can use my equation mass equals moles times molar mass. So my mass equals 0.0105 times 64.1. And my mass equals 0.673 grams. Having a quick look at my question, I only have one significant figure that I'm able to report. So 0.7 grams of calcium carbide will decompose to give me 235 mils of acetylene gas.